In this lesson, we will learn how to compute first and follow sets for a context-free grammar, show derivations that witness follow membership, and discuss whether the grammar can be parsed by recursive descent. Here is the grammar, written clearly. There is a small typo in the prompt. The symbol that looks like the digit 6 should be the terminal B. Also, the non-terminal capital A appears in right-hand sides, but there are no productions for capital A given. We will proceed by computing every first and follow set that does not depend on a definition of capital A, and we will keep first of a symbolic. Let's compute first sets bottom up. For capital B, the rules are little CBA or epsilon. So first of B is the set containing little c and epsilon. For capital C, the rules are BcBa or epsilon. The right-hand side BcBa always begins with the terminal little c, regardless of whether B is epsilon or not. So first of C is also the set containing little c and epsilon. Now, compute first of each right-hand side of the productions. We keep first of capital A symbolic because capital A is not defined in the prompt. Next, follow sets. By definition, the end of string marker follows the start symbol. So the end marker is in follow of capital S. We now scan each production and collect what can appear immediately after a non-terminal. In S arrow AC, AAB, we see three cases. Little c follows capital A, little a follows capital A, and little b follows capital A. Also in S arrow D, AB, little b follows capital A. So follow of capital A is the set little c, little a, little b. For capital B, from S arrow BB, B is at the end. So follow of B contains follow of S, that is the end marker. From C arrow B CBA, little c follows the first B, and little a follows the second B. From S arrow CBC, B is followed by C. First of C contributes little c, and since C can be epsilon, follow of S also contributes the end marker. Therefore, follow of B is little a, little c, and end marker. For capital C, in S arrow CBC, after the first C comes BC with first containing little c, and because BC can be epsilon, follow of S also contributes end marker. The last C is at the end of that right-hand side, so it also inherits follow of S. So follow of C is little c and end marker. Now, for each element Z in follow of X, we will exhibit a derivation from S that shows X immediately followed by Z, or if Z is the end marker, a derivation where X is last. For C in follow of A, S derives a cAaAb, where C follows A. For in follow of A, S derives a cAaAb, where follows the second A. For B in follow of A, either in S derives a cAaAb at the end, or S derives DAB. For C in follow of B, S derives CBC, then expand C to be CBA, so we see CBC derived to be CBABC, where C follows AB. For in follow of B, in C to be CBA, A follows the second B, so S derives BC, B ABC with that after AB. For end marker in follow of B, S derives BB, where B is last. For C in follow of C, S derives CBC, then expand B to CBA, so we see a little c immediately after C. For end marker in follow of C, S derives CBC, set B and the last C to epsilon to obtain a sentential form ending in C, then epsilon. Does this grammar allow standard recursive descent? That is it LL1? For LL1, distinct alternatives for a non-terminal must have disjoint first sets, and epsilon productions must not cause first and follow conflicts. Here, capital C and capital B both derive epsilon, and the production S arrow CBC has first equal to curly brace C and epsilon. That epsilon forces us to merge first of CBC with follow of S. In addition, the rule S arrow ACAAB begins with capital A whose first is unknown and may overlap with other alternatives. Therefore, as written, this grammar is not suitable for direct LL1 parsing. It would require refactoring such as left factoring and eliminating epsilon ambiguities or providing a precise definition for capital A. Now, part 2, weakest preconditions for Hoare assignment triples. We will use the standard assignment axiom. For brace Q brace, after X becomes E, the weakest precondition is Q with every free X replaced by E. In symbols, pre equals Q of E over X. We will handle each subpart by substitution. Where the prompt had minor typos, we state the intended assignment. Let's go item by item. A. Pre such that after x becomes 1, post is x equals 1. Substitute. Pre is true. B. After x becomes 1, post is x equals 2. Substitute. Pre is false. C. After x becomes y plus c, post is 0 less than x plus y plus c. Substitute x with y plus c, giving 0 less than 2y plus 2z. D. After x becomes x times c plus 3, post is x times x greater than y plus 2. Substitute to get left side equal to x z plus 3 squared. E. After x becomes x times c plus 1, post is y squared greater than x plus 5. Substitute to get y squared greater than xyz plus 6. F. Intended assignment is y becomes negative y plus 1. Post is there exists y between 0 and 10, such that z plus y equals 50, with the y inside the post being the new y. Substitute new y as negative old y plus 1. G. After x becomes y plus 1, post is for all z in a given range. X plus 2 to the z is greater than w plus 2. Substitute x with y plus 1. H. After x becomes c plus 1, post is for all z from 1 to less than x. X plus y plus z less than 100. Substitute x with z plus 1, noting the bound uses the same z symbol. I. After x becomes x plus y, post is there exists x in 0 to 10, such that x squared plus c equals 10. Rename the old x to x naught to avoid capture, then substitute x naught plus y. J. After x becomes x plus y, post is there exists y in 0 to 100 such that x plus y equals 15 and z times x plus y less than 100. Substitute x with x plus y inside both conjuncts. Summary. For first and follow, work from nullable and terminal starts, then propagate follows by scanning each right-hand side. Provide short derivations that witness every follow membership. For Hoare logic assignment triples, use simple substitution to obtain the weakest precondition.